Okay, so once again, part 3, trig functions on the unit circle. Okay, good enough. So the learning goals are to find values of trig functions for any angle and find values of trigonometric functions using the unit circle. So when I say any angle, do you see how I'm constrained with triangles? They could only ever be in those first two quadrants and still be a legitimate triangle. Do you see what I mean? There's no way I could have a single angle that's equal to or greater than 180. But with the unit circle, we're freed from that constraint and we can consider any angle that exists. So that's what it means when it says trig functions for any angle. And we'll find values using the unit circle. A quadrantal angle is a multiple of 90 degrees. Multiple of 90 degrees. So 0, 90, 180, etc. Negative values count too. It's anything that terminates on an axis. All right, now the reference angle is, oh, go ahead, buddy. It's any angle or any angle's shortest angular path to the x-axis from the terminal ray. So the shortest angular path to the x-axis from the terminal ray. So wherever the angle stops, what's the shortest angular pathway to get back to the x-axis? So this is always positive. Well, I should say, or 0, because you could have 180 degrees, for example. And in that case, the reference angle is 0. All right, next we'll consider the unit circle, which is a circle with radius equal to 1, and it's used to model all angles. So this is used to understand the trig of all angles. A circular function is any function that's derived from the circle. And trig functions count as circular functions. All right, periodic function. So this is any function that repeats. Like so. Any function that does the same thing over and over and over again. And the period is the portion of the domain over which the function takes to repeat. So if I were talking about this little example I've sketched, that's one period, that's another period, and so on. So how long before the function begins to repeat itself? That is a period. All right. See if I can get most of this up here at once. Questions about anything? Okay, make sure your phones are not a distraction. They should only ever help you. Checking the time is one thing. Using it as a study aid is one thing. Texting in class is another. Okay. So if I were to pick any point in the coordinate plane, some point x, y, I could describe the trigonometry of the angle associated with the terminal ray through that point with these formulas. So everything I'm about to highlight is worthy of note, and I'll blow this up as large as I can. I know this font's kind of small. So we can, and this is using the entire coordinate plane like we used the unit circle earlier. The unit circle is just the simplest version of this because we're picking points that are 1 unit in distance from the origin. So the R is always 1. But we could do that with any point. So if theta is an angle in standard position, in other words, the vertex is at the origin, and the initial ray is along the x-axis in a positive direction, we pick any other point, and we can describe the trig functions of that angle with these formulas. Appreciate you guys taking careful notes. It's a good plan for your life. Most of your, depending on where you go to college, I guess, most of your professors are going to be pretty traditional type, direct instruction focused teachers. Another thing about college professors, people are usually ill prepared for. In high school, pedagogy is a teacher's life work. In other words, the art of teaching is what a high school teacher focuses on. The material is almost incidental. And for a college professor, the opposite is true. The material is their life's work, and the teaching is incidental. So they are, in many cases, less adept at teaching, or at worst, apathetic about the student's result. They have some paper they're working on or some research they're conducting, and that's the focus of their professional life. And teaching is only ever an unhappy chore for a lot of college professors. So that's a shock to some students. Aren't you supposed to love me and take care of me like my high school teachers did? Nope, not always. So let's pick a point. We sketch this point. It'll help us understand this problem. So our point under consideration is -4, +3. And we're considering the angle associated with the terminal ray through that point. Starts at the origin, of course. So this angle, theta, is what we're concerned about. We can describe the 6 trig functions with just the information of a point on the terminal ray. So they give us a point on the terminal ray. We can describe everything else about the trig functions of that angle from that information. First, let's find r. So remember, it's the square root of x squared plus y squared. And so that's the square root of 16 plus 9, radical 25 equals 5. We're only concerned about the positive result here. It's distances. All right. So remember, sine of theta is y over r, which is 3 over 5. Cosine of theta is x over r, which is negative 4 over 5. And tangent of theta is y over x, and that is negative 3/4. Y over r, x over r, y over x. Now, if we pick a point that has a 0x coordinate, this is going to fail, be undefined. All right, now let's talk about the reciprocal functions, which are cosecant, secant, and cotangent. Once we found the original 3, those are easy. You just invert. If you write them this way. Negative 5 over 4 for secant. And negative 4 over 3 for cotangent. You would, of course, reduce these if you could. Allie? Sure. So there's 6 trig functions, and it's a consequence of the nature of a trig function. We're comparing a triangle's sides to each other by division. So with a triangle, you have 3 sides by definition. So the ways I can pick that first side are 3. I can pick any of the 3 sides. But if I'm comparing that to another side, only 2 remain. So I can pick 3 for the first one, 2 for the second one, which gives me a total of 3 times 2 or 6 possibilities. Now these 3 primary possibilities, sine, cosine, and tangent, are determined by SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now the other 3 are considered the reciprocal functions. They're the cosecant of theta, which is the opposite of the sine, in other words, the hypotenuse over the opposite. The secant of theta, which is the opposite of the cosine multiplicatively, in other words, the hypotenuse over the adjacent. And then the cotangent is the reciprocal of the tangent, the adjacent over the opposite. And Cho-Cha-Cow is one way you can remember that if that sticks in your head. It always did for me. That was John Jones's creation. Not exactly original, but functional. Good question. Other questions? All right. So here's one for you. You've got negative 3, positive 6 is a point on the terminal side of an angle theta. Find the exact value of the 6 trig functions, making sure to reduce when possible. You will have some values that reduce here. Let me know if you get stuck. This is about Friday. Be sure also to reduce any radicals you encounter. As a side note, I've also gotten Skyward completely updated again, so glance at that when you get a moment. Hope you understand what's going on. You don't want to be taken by surprise at the end of the 9 weeks. Let's another few seconds and then we'll discuss it. Okay, so you'll remember that sine is y over r, cosine x over r, tangent is y over x, and then we can reciprocate those for a good little shortcut to get the reciprocal functions. Okay, so r, I noticed on a couple of your papers, you wound up with the square root of 9 plus 36 equals radical 45. Whilst not wrong, radical 45 is not fully simplified because it has a perfect square factor. Anytime we have a perfect power of the index under the root, we can simplify. So I can rewrite that as the square root of 9 times the square root of 5, which is 3 on the square root of 5. Because 9 times 5 is 45, 9 is a perfect square. So we can rewrite it like so. All right, so that means this is 6 over 3 on the square root of 5, which is 2 over radical 5 once fully reduced. The cosine is negative 3 over 3. And actually, I need to rationalize too. So that's 2 on the square root of 5 over 5. And then down here, this is negative 1 over the square root of 5, which is negative radical 5 over 5. And for the tangent, it's y, which is 6, over negative 3, which is negative 2. And then we'll just reciprocate those for this value. So that's radical 5 over 2. And I can pick any of these steps to reciprocate at. I'm picking this one because it's the easiest one to reciprocate. So that's negative radical 5 if I reciprocate this step. And the cotangent, negative 1/2. So 2 on the square root of 5 over 5, negative radical 5 over 5, negative 2. And then here's the reciprocal functions. Stop me if you have any questions. I'm going to bet you probably got an equivalent expression for most of those, if not all of them. but maybe the simplification is where you went wrong. And you'll have to be careful with that on the test because you know the answers in the multiple choice test would be in this format. So, and converting to decimals is always an option. And that's a good note for you two ladies taking the ACT tomorrow as well. You can always convert all the answers to decimals, convert your answers to a decimal, and see which one matches. And that would be something you'd employ towards the end. So there's about 10 questions towards the end that they use to distinguish between the high achievers and the highest achievers. So the first 30 are going to be a breeze. 30 through 45 are going to be, easy, but not as easy as the first few. And then the last 15 or so is where you really be challenged. Typically, that's how it goes. All right, common quadrantal angles, 0, 90, 180, 270. So these are the quadrantal angles on the unit circle. There are, of course, an infinite number of total quadrantal angles. But these are the ones we most commonly encounter. So 0, 90, 180, you can write them all on the same axis to save yourself some writing here. Common quadrantal angles, 0, 90, 180, 270. So find the exact value of cosine of pi. So we know this from the unit circle, but let's use an arbitrary point. So pi is over here. So any point in this direction, let's just do -4, 0. That is an example of a point on the terminal ray of pi. So if I were to choose, let me find the r value first of all. So r is the square root of x squared plus y squared. In this case, that's the square root of 16 or 4. So r is 4. And remember that the sine of theta is equal to y over r. But cosine of theta, which is what we're concerned about, is x over r. So this is the formula we're concerned about in this case because we want cosine of pi. So if I take the x value, -4 over 4, it is -1. And we can check ourselves with our calculator. Pi radians. And if you put radians in, guess what mode you have to be in? Radians. This calculator is not psychic. If you leave it in degrees and you try to find a radian measure, it will give you the wrong answer. So that confirms our result. Just as a heads up, let's try the same input in degree mode. You see how it gives us something crazy here. So be conscious of the mode of your calculator. Another tip for tomorrow. Something to be conscious of when you're working through those ones at the end that involve trigonometry. And there'll probably be a few. And there'll probably be a radian and a degree. So make sure your calculator's in the right mode. All right. Tangent of 450 degrees. So we're going off the unit circle here. So we're going all the way to 360 and then 90 more. So we have the same, it's coterminal with 90 degrees. We can pick any point here. I'll pick a point on the unit circle this time. So we want tangent. Remember that the tangent is the opposite over the adjacent, or the y over x. And so that's 1 over 0, which is undefined in this case. Once again, we can test ourselves. I'm already in degree mode. But if I try to find the tangent of 450, it gives me a domain error. We have chosen a value outside the domain of the tangent. Kind of chilly this weekend. I loved it. I love September and October weather. It's the best time to be in East Tennessee. November, just a little too chilly for my taste. And then after that, until about March, you got straight up wintertime. Cotangent of 7 pi over 2. So it won't be as obvious, at least it isn't to me, what's going on with radians. With degrees, I was instantly able to tell 450 is 360 plus 90. That won't be quite as obvious here, at least, again, not to me. So I see that this is 4 pi over 2 plus 3 pi over 2. And this is the largest multiple of the denominator that is even. So that means that's however many unit circles you go. So 2 times the denominator as the numerator makes for a value that's a multiple of 2 pi here. And then whatever's left over is the coterminal angle that's on the unit circle. So this is 2 pi, which is 1 circle around, plus 3 pi over 2, which is like 270 degrees. So this angle is going to look like this, all the way around and then back around to the 270 degree. So we'll pick a point. Again, this time we'll pick the one on the unit circle. That is 0, -1. And we want the cotangent this time, which is the so x over y. So that's 0 over -1, which is 0. So a 0 in the numerator, no problem. A 0 in the denominator, undefined. 0 in the numerator, we don't want. Once again, we're double checking. Mode, radian, 1 divided by the tangent, because it doesn't have a cotangent button on this calculator. Hopefully this will work. 7 pi over 2. It usually works. Okay, so it has a little error. So what it's telling me the answer here is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's telling me this is the answer, but what it means is this. So this is an error that occurs as a consequence of me having to use the inverted tangent or whatever. So the calculator's not perfect. It's given us a very close approximation of the answer here. So the calculator's not 100% reliable in some cases. Okay, so here's one for you. Secant of 3 pi over 2. Well, you just pick any point on that terminal ring, which is 270 degrees. It'll be the same one I picked earlier. Good choice, 0, -1. So that x equals 0, y equals -1. The r is going to equal 1. Secant. So just plug in these values where they go here, and you're going to get an interesting result. This actually looked up the X coordinates. Okay, yeah, you switched to that. That's okay. Trig just requires so much attention to detail. You're so close. So let's use our calculator here to determine the answer, and you can compare it to your result. So the secant is 1 divided by the cosine, and it might give me something funky here too, but we'll see. No, it works. Division by 0, so it does not exist. Undefined is what I'm looking for here. If you got that, pat yourself on the back. If you didn't, it's okay. Get them next time. So reference angle rules. Now, this is your book's take on this. Don't bother to write all this down. What I told you replaces all of this. The shortest angular pathway to the x-axis. So just take the shortest path possible to the x-axis, make it positive. That replaces all this mess. Okay, so sketch -150 and then find its reference angle. A little bit sharper than that. So this is -150 degrees. And now its reference angle, which will be this, is 30 degrees. And normally, if we have a name for the primary angle, which we'll call this one theta, then its reference angle is called theta prime. We put a little tick mark on the variable to indicate it's a reference angle as opposed to the original angle. Sometimes in a mathematical analysis, it's advantageous to use the same variable for two different things because you want to show they're related, but you also want to be able to make a distinction. So this tick mark is often used to that end. And it's called the prime of that variable, theta prime. 3 pi over 4. Let's find its reference angle. So 3 pi over 4 is 135 degrees. Looks like this. And then its reference angle, theta prime, is going to be pi over 4. How many radians does it take to get down to the x-axis? This plus what value would be pi? Well, pi over 4. So this is still somewhat mysterious to you. Again, we're trying to get to the x-axis, and the x-axis would be pi. So pi minus 3 pi over 4 is another way you could do that. That's the book's calculation method. For me, it's easier to just kind of visually analyze it. I'm a very visual person. But if you need to rely on this algorithm, feel free. So here you go, 520 degrees. And so that's 360, and then 60 is 420, 160 more. Tell me what the reference angle would be. So how far would I have to travel to get to the x-axis angular? Okay, so what would my theta prime be in this case? Okay.
20 degrees.
Very good. Any questions about that? So, trig functions of any angle. It's important for you to note that the reference angle will have the same absolute value as the original angle when plugged into any trig function. So if I plug the reference angle in, so if I plug in theta prime, it's going to have the same absolute value as theta. So in other words, no matter which trig function I pick, this will be true. So reference angle trig values will always be positive because they're all coming from Q1. Your shortest angular pathway to the x-axis is always a positive angle in quadrant 1. And those are all positive, as you know. So the negatives are what we'll have to figure out or infer by quadrant location. We can use a reference angle to quickly know the trig value of a function because we've got quadrant 1 memorized so well. And then we just look at what quadrant the terminal ray lies in to determine whether it's positive or negative. Just kind of a shortcut for evaluating some trig values. And a good use of the reference angle. So finding the exact value of sine of 4 pi over 3. Now, we've already evaluated this, and we've solved it with the symmetry of the circle. But 4 pi over 3 is down here 240 degrees. But its reference angle, theta prime, is pi over 3. So I know the sine of 4 pi over 3 is going to have the same absolute value as the sine of pi over 3. And I remember from my unit circle that that is radical 3 over 2. So it's going to have this for its absolute value. But we're in quadrant 3. So in quadrant 3, the x and the y are both negative. The x in this case being the cosine, the y being the sine. It's moot because it's the case for both of them, but it's negative radical 3 over 2. So the information of being negative comes from its position in quadrant 3, and the information of this value comes from the trig function's value of the reference angle. Just kind of a little shortcut. We know its value in quadrant 1, so that's its absolute value. We know its quadrant location indicates that it's negative. So it's negative radical 3 over 2. So what we solved using the symmetry of the circle back on Friday, here they solve using a reference angle. Let me know if anything confuses you guys. Maybe all of it does.
I'm confused on how you know what, like, where the angle would be when there's pi in the.
Oh, I see. Well,
And
I
I
have a-
remember last year I was doing like a table for it.
yeah, the
No.
unit circle,
Yeah.
which is what we did Friday.
Oh, okay.
Make sure and watch that video. So the radians are another way to describe angular deflection. So when I rotate at a central point, we describe it with degrees sometimes, but also with radians. And remember that the key, the Rosetta Stone, if you will, is that one circle is 360 degrees or 2 pi radians. So if I want to convert radians to degrees, I'm going to multiply by 180 over pi, and I'll see that this is, the pi's will cancel. 4 times 180 divided by 3 is going to become 240. So the 240 degrees is probably going to make more sense to you than this for now, but you do need to be able to go back and forth between radians and degrees, because going forward, you're going to see radians a lot more than you'll see degrees. I guarantee. It's just a more elegant way to describe angular deflection. So once you get into higher mathematics courses, this becomes the standard, not degrees. But good question. I appreciate that. Always feel free to ask me. Okay, so tangent of 150. So there's 150 degrees. And our reference angle is going to be 30. And remember that the tangent of 30 degrees is going to be the absolute value of the tangent of 150 degrees. We're going to have to decide whether it's positive or negative, but this will tell us what its absolute value is. So if I go to 30 degrees here, and I pick a point on the unit circle, you'll remember the x-coordinate there was radical 3 over 2, and the y-coordinate was 1/2 on the unit circle. So if I take the x divided by the y, using that point on the unit circle, I'm going to get radical 3 over 1, or just radical 3. So the tangent of 30 degrees is radical 3. Your calculator can give you a decimal approximation. Sure I did that right. X, Y, tangent is X over Y, or is it Y over X? I think I screwed those up, I'm sorry. Because that's not going to come out right. Yeah, I should have said Y over X, my bad. Yeah, so switch these around. Y over X. So 1/2 divided by radical 3 over 2 is 1 over the square root of 3. And if I rationalize, that's radical 3 over 3. And if I take the square root of 3 divided by 3, gives me the same decimal value. So all your calculator can help you do is maybe do what it did there for me, control against a mental mistake with a decimal approximation. Okay, so we've got the tangent of 30 degrees, and how does that relate to the tangent of 150 degrees? Well, these share an absolute value. So it's either going to be this positive or negative. The tangent is the ratio of the sine to the cosine. So we're comparing those by division. In quadrant 1, both are positive. A positive divided by a positive is positive. But in quadrant 2, the x is negative and the y is positive. So a negative divided by a positive is negative. The tangent is negative in quadrant 2. And you can also use your calculator to help you with that. So in Q1, and it's probably a good idea to take a moment and really consider the signs positive and negative in different quadrants. So if I were to take the 4 quadrants of the circle, x is greater than 0. We discount the origin, and y is greater than 0 in quadrant 1. X is less than 0, y is greater than 0 in quadrant 2. X is less than 0, y is less than 0 in quadrant 3. X is greater than 0, y is less than 0 in quadrant 4. So that's something you should have at the ready mentally. Most of you guys could do that if you just thought about it for a second. But when I'm pulling out these positive and negative stuffs, this is what I'm drawing from. And remember, with respect to the unit circle, the x is the cosine of that angle, and the y is the sine of that angle. So this adds a little bit of a new dimension. So where we're talking about the trigonometry of any angle, the cosine is positive in quadrant 1 and the sine is positive. The cosine is negative in quadrant 2, the sine is positive. Both are negative in quadrant 3, cosine positive, sine negative in quadrant 4. So when I said I'm dividing the sine by the cosine, the x by the y, that's how I determined the tangent had to be negative, because we've got different signs in Q2. That argument might have seemed a little mysterious if you didn't have this information at the ready. Okay, so secant of 15 pi over 4. So here's an example of one we really need a reference angle for, because that's a mess. So let's think about this. 4 times 2 is 8. So I can rewrite this as 8 pi over 4. And the reason I chose that is that's a multiple of the 2 pi. That's unit circle. One circle. And we're left with 7 pi over 4. So this angle is all the way around and then back here into Q4 with 7 pi over 4. And its reference angle is going to be pi over 4. So the secant, remember the secant is the inverse of the cosine. So it's the hypotenuse over the adjacent, or in this case, we use r over x. So if I pick that point on the unit circle, pi over 4, remember that it was square root of 2 over 2, comma, square root of 2 over 2. The radius is always 1 on the unit circle. So that just makes your life easier. 1 over the square root of 2 over 2, which is 2 divided by the square root of 2, which is square root of 2. Now that's its absolute value, because we got it from here. Now we need to determine whether it's positive or negative. So the x coordinate is positive in Q4. And so if I reciprocate a positive value, the result is still positive. So yes, it is positive. We'll check ourselves with the calculator here. Once again, make sure you're in the right mode. Radians this time. Notice I'm going back and forth a lot. 1 divided by the cosine of 15 pi divided by 4 is that value. And if I test that against my answer, I see it does indeed match. All right, questions about this? Some of these are just, I don't know, they're going to be difficult to grasp until you do a little drill and practice work with them. All right. So here's one for you. Tell me the cosine of 4 pi over 3. That's on your unit circle. So finding the answer will be trivial. Can you do it with the reference angle and sine, quadrant sine analysis and so on? I believe we might have the heat on.
Sure. So starting with the x-axis, let's trace out 4 pi over 3, which is 240 degrees. I'm taking that angular pathway. So for this one, 4 pi over 3, that's pi, and then pi over 3. So for this one, same thing, pi, and then pi over 3 more. 150 degrees, for example, is 90 degrees and then 60 more. So I'm just breaking it up into the closest quadrantal angle and how much more it's about. That's the way I do it mentally. It's not the only way to do it.
And that makes the x.
Yeah, so to get to the x-axis here, you're going to have to go pi over 3. So pi over 3 is your
Okay, that makes sense.
complementary angle or the reference angle.
Mhm.
So pi over 3 is going to have the same absolute value when I plug it into the Trig function. And so we know the cosine of pi over 3 from the unit circle, that's the x coordinate. So that's going to be 1/2. So we know its absolute value is 1/2. So the question is, in quadrant 3, what is the cosine, which is the x coordinate? Is the x positive or negative? So it's negative.
That makes sense. Thanks.
All right, so the answer you should arrive at is negative 1/2, but what I'm concerned about here is, did you find that pi over 3 was the reference angle, and that if I consider quadrant 3, the cosine is less than 0, the x coordinate or the cosine is negative. I don't know why my less than sign looks so weird right there. So cosine is less than 0, meaning it's negative. Pi over 3, the cosine value is 1/2. And so we see that it's negative 1/2. Okay, so let cosecant theta equal negative 3. The tangent of theta is less than 0. Find the exact values of the 5 remaining trig functions. So we're going to use a reference triangle, but we need to do a little quadrant analysis. So where is the tangent negative? Well, that's going to be in Q2 or Q4. And the reason why I say that is in Q2, it's going to be the ratio of a positive to a negative. And in Q4, a negative to a positive. And so in both cases, the tangent, the x divided by the y, or the y divided by the x rather, is going to be negative. So this is only true in quadrant 2 or quadrant 4. The cosecant of theta, so this is the inverse of the sine, and it is also less than 0. So the sine or the y value has to be less than 0. And that's only going to be the case in Q4. So I've determined our angle location is in quadrant 4. That tells me all I need to know. Now I can use a reference triangle to find all my remaining values. So I've got some angle theta, and the cosecant of theta is -3. Remember that the cosecant is the hypotenuse to the opposite. So 1 squared plus our unknown side, b squared, has to equal 3 squared. And don't use negatives for distance on a triangle, in case you're wondering why I didn't include that negative. Distances are always positive. So this is 1 plus b squared equals 9. B squared, b equals the square root of 8. Well, I don't want to skip a step. B squared equals 8. B equals the square root of 8, which is the square root of 4 times the square root of 2, which is 2 on the square root of 2. Now I need some room, so I'm going to clear all this up. All right, so the sine of theta, cosine theta, and tangent theta. With respect to this little reference triangle, the sine is the opposite over the hypotenuse. Remember, we're in quadrant 4. Sine is negative in quadrant 4. The y value or the sine is negative. So 1/3, -1/3. The cosine is positive. The x value is positive in quadrant 4. So that's 2 on the square root of 2 over 3. And then the tangent is opposite over adjacent, also negative in Q4. So let me rationalize here. So there's the sine, cosine, tangent. Now the cosecant we're given is -3. The secant is 3 over 2 on the square root of 2. So I'm going to rationalize here. 3 on the square root of 2 over 4 is what I wind up with there. And then the tangent of theta is going to be -2 on the square root of 2 divided by 1, or just -2 on the square root of 2. Nope, cotangent. Sorry, yes. Brain's in low gear today. So that's about as hard as it gets for chapter 4, part 3. Can you put together everything you know about geometry, triangles, the coordinate plane, et cetera, et cetera? So this sort of aggregates all those skills into one problem. And it will help reveal weaknesses or display your strengths, depending. All right, ladies and gentlemen, so we'll call this section complete. Your task is going to be page 251, 2 through 26 even. So it's 13 problems or 14 problems. Let me know if you get stuck on something.